Hey guys, today we are looking at 5.4, which is all about types of solutions. This will be both our notes and our homework, so that is within the same worksheet. So we're going to go through a couple of problems together here for our notes, and then the rest of this will be for you to finish for homework for today. So for our last section of Chapter 5, which is all about systems of equations, we're looking, as the title says, at different types of solutions. Now, everything that we've seen so far this chapter has been something that has a single solution, right? We've been able to solve it with a single x, y coordinate that is the solution to that system, right? That's the x and y coordinates that work the same, that both work in both of our two equations. So for this one, it's also going to be a nice review. We'll kind of bounce around the different types of solving problems. And it's going to be up to you on what you want to do. Again, like I've said before, on the quiz that we'll have over these 4 sections, there are going to be some problems where you have to solve it with a particular method, but there's also going to be a section where I just say solve the system. So it's going to be up to you on whether you choose to solve using substitution, solve using elimination, or if you want to solve by graphing. So we're going to try out a bunch of different ones here, just to kind of see what they look like. So in this case, for number 1, if we started with this problem, it is going to be up to you on which one we do. But again, I want to show you each of the different methods. So for number 1 here, we're going to go ahead and solve this using graphing. Since both of these are set up already with slope-intercept form, we're going to go ahead and graph the bottom one here in blue and the top one here in red. So if I'm going to graph that top one, my y-intercept, which is what we always start with, is positive 1. So I'm going to kind of scroll back and forth. Positive 1 is my y-intercept. My slope is 2/3. So we know if 2 over 3 is my slope, and this is rise over run, that means I'm going up and to the right, since they're both positive. So I'm going to go from that point that I just plotted, up 1, 2, over 1, 2, 3. And I have that second point. I will go ahead and grab the ruler and get it lined up as best I can. That looks about good. Draw my line through. Arrows on the end. And I'll go ahead and switch to my blue. My blue equation is y equals negative 1/2 x plus 8. So positive 8 is the y-intercept. Here, with my slope being negative 1 over 2, I can either say it is negative 1 over 2, which would be down 1 and to the right 2. Or I could say it's 1 over negative 2, which would be up 1 and left 2. Either way, it does not matter, but you got to just make sure that since it's a negative slope, one or the other gets that negative sign. So I'm just going to go ahead and say down 1 and right 2 is that point right there. I will once again grab my ruler, get it lined up as best I can, and looks like right about there. All the way across. And this point right here, let's do it in yellow. We'll highlight it here. And we'll write it in black. Looks like 6, 5. 6, 5 would be my solution. Pretty normal problem. We get a single solution. We get a single intersection of my two equations. And we're all happy, right? So far, so good. All right, let's jump down in here to number 2. Number 2, let's go ahead and solve using substitution. This one is set up nicely for substitution. I can see that in my top equation, y equals 3x plus 1. So I can go into my bottom equation and replace y with 3x plus 1. So I'm going to go ahead and do that right below. 2, and then I'm going to replace 3x plus 1 for my y equals 6x plus 8. So now I've got an equation that just has x's involved, which is nice. I'm going to go ahead and distribute my 2 into my parenthesis. That gives me 6x plus 2 equals 6x plus 8. And some of you might be able to see ahead of time something weird's about to happen, all right? When we subtract 6 to try and get our x's together, subtract 6x from both sides to get them together, my x's go away over here and over here. So I end up with 2 equals 8. Now, this process should look familiar to us. We saw this way back in chapter 1. If we ever have a situation where in the process of solving an equation, we end up with our variables completely going away, then we have to look at those two special cases. So those two special cases, remember, are either no solution or all real numbers. And which one it is determined by whether or not this equation that I'm left with is true. So these two numbers, obviously different. So this equation is not true. So my answer would just be no solution. NS. Now, just for reference, I'm not going to graph that, or, well, I probably could. We could do that real quick, because I do want to show you what it looks like graphically. If you're doing these problems with either substitution or elimination, it's still going to be set up the same way we would usually start a problem. It's just that in this case, both my x's and my y's are going to go away in the process of solving. And from there, we can just conclude if that equation that I'm left with is true, then it's all real numbers. If it's not true, it would be no solution. But I do want to show you what it looks like graphically, because that one's a little bit different. So in this one, my top equation, which, again, I'm going to go ahead and do in red, 3x plus 1. All right, so positive 1. Slope of 3 is 1, 2, 3 over 1. So we've got, grab our ruler, get it lined up. Yeah, that's good, right there. Move it on over. Arrows on the end. Our bottom equation, we're going to have to rearrange a little bit to be able to put it in slope-intercept form. So I have to divide by 2 all the way through to put it in slope-intercept form. But I end up with y equals 3x plus 4. So if we go back over here, now positive 4 is my slope, and my y-intercept, and up 1, 2, 3 over 1 is still my slope. So I end up with this line, which if you look, those two lines are parallel to each other, but parallel and separate. So they're parallel to each other, but they never intersect, which makes sense because for us, where my two lines intersect is the solution to my system. And if they never intersect, there's no possible x and y coordinate that is true for both of those two equations. So if you are going to solve by graphing and you end up with two parallel lines that never intersect, that tells you again that it is no solution. And again, just NS is fine. If you want to abbreviate it, NS, and then we'll see with other possibilities, infinitely many solutions, not all real numbers, which I think I said earlier in the video. Infinitely many solutions. IMS is our other option. Okay, so let's hop on down to the third and final problem that we'll do together. For number 3, this is set up nicely for elimination. We've got our x's and y's on the same side over on the left. So for this, I don't immediately have elimination ready for us. Right? We can't add them up and have my x's go away, or add them up and have my y's go away, because I don't have those coefficients that match with one positive and one negative. So it doesn't matter which variable you choose. I can either try and get my x's to eliminate or my y's. It doesn't really matter, and just for convenience sake, or because it's the furthest to the left, I'm going to go ahead and try to eliminate my x values. So if I'm going to try and eliminate my x values, I need to get my numbers, my coefficients attached to x, to be the exact same number, but with one positive and one negative. So my top is already a positive 2x, so if I can multiply this bottom equation to make it a negative 2x, then that would make my x's eliminate. So I'm going to go ahead and multiply this bottom equation by 2. And I'm going to go ahead and rewrite. These two equations become, well, my top one didn't change. I didn't multiply that one by anything. And now to get my x's eliminated, I multiplied by 2 all the way through. So that's a negative 2x now. This becomes a positive 4y, and this becomes a negative 4. So the elimination process now, I can go ahead and add up going down, and that cancels out my x's. It cancels out my y's, and it cancels out my numbers. Oh boy. So we have to remember here, when they cancel out, that really means they add up to 0, which is the same thing over here. 0 and negative 4 adds up to 0. I mean, technically on the left side there, we have 0x plus 0y equals 0, but then it just, 0 equals 0. Which that, again, is always true, right? There's no possible thing we could plug in there that would make 0 not equal to 0. So this, instead of no solution, we would call this infinitely many solutions. IMS is what I usually abbreviate it to. Most people struggle with spelling infinitely in the first place, so IMS is perfectly acceptable. Plus, it's 3 letters versus however many that is. I'm not going to count. Graphically, again, this one is a pain in the rumpus to try and solve by graphing, but I'll just kind of explain to you what this would look like. In this case, if you were to solve by graphing and you had infinitely many solutions, IMS, it would be something like this, where I end up with the exact same line. So you graph it the first time, and this is my first equation, my bottom one in blue. Sure, we're just going to pretend. This is not the accurate graph, so don't try and look at this and then get confused why it doesn't match the equations. I'm just showing you an example here. So if that's my first one, I then rearrange my equation, and I end up with something that looks very similar. In fact, has the exact same slope and the same y-intercept. The two lines are overlapping everywhere because there are infinitely many possibilities where those two lines intersect with each other. So that's what they look like. Those are our 3 different possibilities for types of solutions. We could have exactly one solution. We could have 0 solutions, which would be no solution. Or we could have infinitely many solutions. So that is, that is it for this last set of notes. This is actually the last section for Chapter 5 that we're covering. The last 2 or 3 sections we're just going to skip over this year. With some other weird stuff and, trying to get caught back up a little bit. So your homework for tonight is actually the back side of this page. So they might be front to back. It might be right next to each other in the packet that I gave you guys back in the first week of January. But on the back side here, taking a look real quick, there are 9 questions you guys have to do. And for these, all you have to tell me, you don't necessarily have to solve it, but really you kind of need to get to the point where you know how many solutions there are. And you're just categorizing them into those 3 different options for how many solutions there are. So you're going to go through and solve the system however you want to. If you want to solve by graphing, because that's your preferred method, you should have some scratch paper, some graph paper available to you. If you're strictly remote and you're watching this and want some graph paper, again, I have that posted on Classroom under the Resources tab. If you're in person, I do have some graph paper over on the side wall, the hallway wall underneath the cabinets. But if you want to solve by graphing, again, feel free to do that. I prefer substitution or elimination, but that's just me. You guys don't have to use any particular method. It's up to you guys. But again, you'll figure out how many solutions there are, and you'll write the letter that you solved in either one solution, no solutions, or infinitely many solutions. So if you go through and do letter A and you say, oh, hey, that's no solution, then you'll write A under no solutions. I just made that up. Again, don't trust me. Do the problem. Figure it out yourself. All right, guys, that's all I got for you. If you have any questions, as always, feel free to reach out and let me know. If you have any questions, concerns, thoughts, ideas, hopes, or dreams. If not, have a fantastic day, and we will see you guys soon.